Hi, Yul. Today we're going to be carrying on with a bit more pure stuff, looking at sequences or series, which isn't too tricky. Actually, we're going to start off with something called recurrence relations, which is just how a different way of writing down sequences than we used to have in GCSE. Actually, there was a bit of it in GCSE. It's talking about the iteration and what the basic rule is that you can follow to make any series that you like, really. So we'll have a look at that. Now, there is going to be a requirement from now on that I show whether or not you have submitted anything and taken part in lessons. So although we're not corresponding face to face all the time, and these aren't live lessons, within 24 hours or so, if you haven't uploaded something to me either on class charts or by email, I will be listing it as not submitted. Okay, so try and view this as a way of just helping to gently nudge you along there. I'm not going to be going back to all the others straight away. Actually, I think I will. Yeah, I will go back to the others, but it'll take a little while to catch up. And so those of you who've submitted work to me all the way along there, you've got nothing to fear at all. It'll all just be sort of down there as submitted. Those who haven't, it will be showing up saying where you need to do more work, and it's all for your benefit, because if you do all of this work, I think you should end up being very happy with the result you get from the mock, and hopefully that means your final A-level grade. Right, we've had a lot of stuff on paper, so I thought we'd do a bit of stuff on the board today. So pause the video, have a look at that, and all I'm going to tell you before you have your go at it is it's really quite simple. It looks weird, but it's quite simple. You may well remember this, or you may be thinking, oh yeah, what's going on here? Just have a little go, even if it takes you 5 minutes before you go, and come up with something that would be the first 5 terms of the sequence. Okay, pause it now. Right, so what this does mean is n is bigger than or equal to 1 means you start, that's another way of just saying you're going to start with n being 1. So remember when we did the nth term, sort of going back years and years, n stands for the first term, n is 1, isn't it? For the 10th term, n is 10, and so on. So you're starting with 1. Now it's saying the first term is 10. Then it's saying for the next term, you take the term before that and do this to it. It says 3 times, so you're timesing it by 3. So all we're doing is timesing by 3 to get 30. Then for the next one, for the next iteration, this becomes, your 30 becomes into here, and you're saying, right, you're going to take that and times it. That becomes your UN, and then for the next one up, you need to go to there. So it's timesing by 3 would get you to 90. So then for your next term, your 90 goes in there, and for your next term, you're going to be saying 3 times that 90 will give me my next one, and you just keep on doing that. So that gets you 270, and for the 5th term, if you times 270 by 3, you get 810. Right, write this one down and have a little go. If you're confused, just start with the first term of the sequence and keep working it through until you get to 95. It doesn't take very long. So here goes. If you haven't done it, make sure you have paused the video and do give it a go beforehand. So we're going to start with 4 because that's the first term of the sequence. So if k was 1, then that would have to be 1, wouldn't it? So now this is saying we times by 3 and then we take 1 to get the next term. So 4 times 3 is 12, 12 take 1 is 11. Then 11 times 3 is 33, 33 take 1 is 32. Then 32 times 3 is 96, 96 take 1 is 95. So that's your first term, that's your second, that's your third, that's your fourth. It's asking you which term It is. So k equals 4. All there was to that one. Right, now this is kind of a beautiful one here. Pause it and have a think about it. So we've got a sequence where you're just getting two numbers recurring. Now there are many ways you could solve one like this. But if you haven't got any idea at all, if you've got an idea, then pause it and make sure you've done it before I carry on, because I'm about to carry on. I'd like to think about two things. One is 4 plus 7 equals 11. Another is 4 times 7 equals 28. But you need to think about the inverse relationship to get there. So I'm going to carry on in 5 seconds. Right, so if your first sequence, your first term, whatever, is going to be 7. So you can get 1 mark just for writing U1 equals 7. You've got to do that, whatever. But it's the next bit where the clever bit comes in. We've got to think about what would we do to get to there. But instead of thinking about what you do to 7, what can you do with 7 using one of these facts? So then you could say, to get your next term in your sequence, if you had 11 and you took the previous term in the sequence away, you would get there, because 11 take 7 is 4. Then on the next one, 11 take 4 would be 7, and so on. Or we could have the first one being 7, and then because we know 7 times 4 is 28, we could say 28 divided by un, or you could say 28 over un, couldn't you? And that would get you there as well. Here's another one, so have a look at that and think about it. Now all of these are really, the maths in them is very, very simple in terms of the arithmetic, but the thinking is creative and subtle and sophisticated. That doesn't mean that it isn't very simple. It is very simple. So if you haven't had a go already, make sure you pause the video and do that. You know that you're starting with 7. Then what are we doing? We're going to say that the next term is going to be that 7 plus n. Well, what's n? Well, n, for the first 5 terms of the sequence, n will be 1, 2, 3, 4, and 5, won't it? And then that just keeps on going. So for the first one, for the second term, you're taking the first term and you're adding 1 to it, because that's your first value of n. So 7 plus 1 gives us 8. Then for the next one, you're going to have 8, and the term that goes with that is going to be the second is going to be 2, because it's the n at the same bit. So for the second term, n is 2. So 8 plus 2 is 10. For the third term, you're going to have, or for the fourth term, you're going to be looking at the third term, which is 10, and adding 3, which is the value of n for that term, 13. And for the fifth one, you're going to be taking the 13, which is the fourth one, so you're going to add 4 to it because it was the fourth one, and it gives you 17. And that is all that is. Right, now we're going to add in some sigma notation. So remember what sigma's meant to use, and for those of you like using Excel, you'll be very familiar with this symbol from there, where they use it for adding up everything in a column in one go. You can do all sorts of little programmy things with it. So I'm going to put this down here for you, and So what does this mean? This is saying, this up here is telling us how many things we're going to have in our series that need to be added up. When you've got the sigma thing, it's saying the sum of all of these things. And this is here, R, is telling you which number you are starting with. So, and this here is telling you what the rule is. So what you're doing here is you're adding, this is saying what the number is, this is what the rule is, so you're starting with 1, the rule is 1, so sigma here, you would just be adding up however many you've got. So if you had got, and the sum of all of that is going to be that, what this is saying is 1 plus 1 plus 1 plus 1 is going to give you 4, isn't it? So you'd have the same amount there. Let me give you another one which will give you a bit more of an idea of therefore where we're going with this. Right, so now we've got this, so have a little go. So the R is telling you it's basically like the nth term, but we're using R instead of n. So R is your first is the first value you put into this rule, and then it's going to be the second one, your R will equal 2, and then the third one it will equal 3, then it'll equal 4, then it'll equal 5, just like with the nth term. So for the first one you're going to have 3 R's, 3 1's being 3, plus 1 makes 4, 2 3's are 6, plus 1 is 7, 3 3's are 9, plus 1 is 10. Or you could just think of it as an nth term, and you're going up in 3's each time, aren't you, because it's linked to the 3 times table. So it'll go 13, 16, 5 times 3 is 15, plus 1 is 16. And then the value of the sum is just going to be 4 add 7 add 10 add 13 add 16, which you can do in your calculator, and you should get 50. Right, I'm going to give you another one of those to have a go at. Okay, so again, pause the video, have a go at this one. So the first one, I would, to get this right, what I do is write down first of all what my square numbers are. So R is 1, so 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. Because we've got a 6 up here, that means we've got 6 terms in this series. 6 squared is 36. Then because it's actually 3r squared, not r squared, we need to times all of those by 3. So our actual series is 3. 3 times 4 is 12. 3 times 9 is 27. 3 16s are 48. 3 25s are 75. And 3 36s are 108. And then the value of the sum, well, you just add them all up, and you should get 273. One more of those coming up. Oh, ouch, I can hear you cheering there. A bit of trigonometry just suddenly popping in for no good reason other than we can. So give it a go. By the way, that's a degree symbol, not a 0. That would make a difference. So this is what we get to. You stick in R as being 1, and then R is 2. 2 times 90 is 180. 3 times 90 is 270. 4 90s are 360. 5 90s are 450. You just do the sin of that. Draw your little curve if you like, because it's going up to 1 and down to -1, isn't it? So we're getting a 1 first up at sin 90, and then we're getting, so we're actually looking at the curve between there and there, and because we're getting 2 positive 1s and only 1 negative 1, our sum is +1 when we add them all together. Right, so here's your final example, and then you should be ready to go off and do the Maths Genie worksheet, just a 4 or 5 questions on there would be great. So pause the video and have a little go. So the first part, I reckon, is probably the trickiest bit here, just getting into it. So the first one, A is K. So A1 equals K. A2 is going to be 4 times K and then add 5. And then to get the third one, you're going to have to take this and put it back into there. So A3 is going to be 4 times 4K plus 5. So if we multiply both of those, we get 16K, and 4 times 5 is 20. So you get 16K plus 20. And then when it comes to showing that it's a multiple of 5, you need to be, well, we've got the first 3 there, so the fourth term is going to be 4 times the third term and then add 5, which is 4/16. Oh, sorry, we haven't got all of that on there. Let's bring it in like that. 4 times 16 is 64K plus 80 plus the 5. So that's giving us 64K plus 85. So then what we need to do is add them all together. So we're going to have the sum of the first 4 terms is going to be K plus, so that's the first term, the second term 4K plus 5, the third term 16K plus 20, the fourth term 64K plus 85. Now just taking our time here and make sure we simplify correctly, we've got 5K plus 16 makes 21, plus 64 makes 85K, which is good because that's a multiple of 5. And then our plain numbers, 5 add 20 is 25, plus, so 25 plus 85, have I missed something there, is, I thought I got to 135 when I did this before. Let me just check. Ah yes, I've made a mistake going back here. You probably spotted it. I needed to add 5 to that one, didn't I, when I did that? So that should have given me 20 plus 5, giving me a final answer of 16K plus 25. And that's going to have a knock-on effect over here. That'll be 100 plus 5 is 105. So I need that 105 in there. 130, yeah, 135. So that is going to mean I can take a factor of 5 out of both of those, and we've got 17K plus how many 5s in there, goes twice with 3 left over, 27. So that shows that we've taken a factor of 5 out of it, and as long as K is a whole number, then it must be a multiple of 5. So now, as I said before, if you could have a go at all those questions on the Maths Genie sheet and upload some of that to show me how you've got on, and let me know if you've got any problems or if I've made any glaring errors.